The data packet arrives at NASA's mission control after a 4.5-hour signal delay, and the room erupts. But not for the reason anyone expected. The images show mountains 11,000 feet tall, made of water ice, a heart-shaped plain the size of Texas, with no craters at all, and a haze layer wrapping the atmosphere in blue. Pluto is not dead. It is active, complex, and nothing like the frozen wasteland science promised it would be. Scientists had spent decades building a mental picture of Pluto as a cold, inert lump, drifting at the solar system's edge. The models were confident, the predictions were consistent, and nearly every expert agreed on what New Horizons would find. What it actually found broke those models in the first hour of data. No craters on that plain means the surface is geologically young, reshaped by forces nobody had accounted for. Something out there, 4 billion miles from the sun, is still alive. Before New Horizons, Pluto was a punchline, the little world that got kicked out of the Planet Club. Scientists weren't expecting much, and honestly, the physics backed them up completely. Pluto sits roughly 40 times farther from the sun than Earth does, soaking up almost no heat at all. At that distance, temperatures drop to around -230 degrees Celsius, cold enough to freeze nitrogen solid on the ground. Without internal heat and without solar energy, there's simply nothing left to drive geology or weather or change of any kind. The leading models painted a picture of a cratered, ancient surface, battered by billions of years of asteroid impacts with zero erasure. Think of the moon, but darker, colder, and even more forgotten by time. Every crater that ever formed would still be sitting there, perfectly preserved, a fossil record of the solar system's violent early years. That was the consensus, a dead world, locked in place, waiting to be confirmed. The first images from New Horizons hit scientists like a punch. Nobody was ready for what they saw. Rising from Pluto's surface were mountains, real mountains, jagged and sharp and impossibly young-looking. They stood 11,000 feet tall, roughly the height of the Rocky Mountains here on Earth. Water ice built them, not rock, because that's almost all Pluto has to work with out there. Water ice at those temperatures behaves like stone, rigid, load-bearing, capable of holding a peak for billions of years. That part made sense. What didn't was how the mountains got there in the first place. On Earth, mountains rise where tectonic plates grind and collide with enormous force. Pluto has no large neighboring body to squeeze it, no tidal flexing to pump heat into its core. Something inside that frozen world was generating enough energy to push up terrain, and nobody had predicted it. The old model said Pluto should be geologically dead, a relic, unchanged since the solar system's earliest days. These mountains were proof that the old model was simply wrong. Then the cameras turned toward the bright region dominating Pluto's face, and everything got stranger. Scientists had already named it Tombaugh Regio, a vast, heart-shaped plain roughly the size of Texas and Oklahoma combined. What they expected to find inside it was a battered, ancient surface, pocked with craters from billions of years of impacts. What they found was nothing. No craters at all, not a single one across an area that should have been collecting scars for eons. A crater-free surface means only one thing in planetary science. Something is actively erasing the past. The culprit is a slow, churning process called nitrogen ice convection, where frozen nitrogen heats from below, rises, turns over, and buries any crater before it can survive. Pluto, 4 billion miles from the sun, is still turning itself inside out. The heat driving this process almost certainly comes from Pluto's own radioactive core, not from sunlight. That single plane rewrote the definition of a geologically dead world. When New Horizons turned its camera back toward Pluto, scientists expected to see nothing but black. Instead, they saw a thin, glowing ring of blue wrapped around the entire planet. That blue isn't scattered sunlight the way Earth's sky works. It's something stranger. Tiny particles called pholins form when nitrogen and methane get shredded by ultraviolet radiation high in the atmosphere. Those particles scatter blue wavelengths back into space, producing a haze that layers itself in distinct, visible bands. Pluto's atmosphere is so thin it barely registers, less than 1/10,000th of Earth's surface pressure. And yet, it's doing something chemically alive, building complex organic molecules billions of miles from the sun. The same tholins coating that haze drift down and stain Pluto's surface in patches of deep red and brown. One world, one process, connecting the sky to the ground in a continuous chemical conversation. That's not what a dead rock does. Every single feature New Horizons found on Pluto points toward the same uncomfortable conclusion. A world that small, that far from any meaningful heat source, should be geologically dead. Instead, Pluto is cycling nitrogen, building mountains, and resurfacing itself on timescales that rival active planets closer to the sun. The ice mountains aren't just tall, they're young, which means something is still generating the energy to push them upward. Sputnik Planitia isn't a scar from ancient history, it's a living, churning engine sitting at the heart of the planet. Even that thin blue atmosphere refuses to behave like a relic. It responds, it shifts, it interacts with the surface below. What ties all of this together is a simple and genuinely unsettling idea. Internal heat can persist in small, cold worlds far longer than our models ever allowed. Pluto didn't just surprise us, it broke the framework we use to understand planetary geology. Back in 2006, the International Astronomical Union voted Pluto out of the Planet Club, and millions of people took it personally. The decision came down to one rule: Pluto hadn't cleared its orbital neighborhood of other debris. But New Horizons arrived 9 years later, carrying evidence nobody had prepared for. A world with mountains, flowing nitrogen ice, and weather systems doesn't exactly scream cleared nothing, built nothing. The IAU definition says nothing about geology, nothing about complexity, nothing about a world that actively reshapes itself. Scientists who study planetary surfaces will tell you, Pluto behaves more like a planet than some objects we've never questioned. That's not nostalgia talking. That's data from a spacecraft that crossed 3 billion miles to find something extraordinary. The demotion was based on orbital mechanics, and the flyby answered a completely different question. What New Horizons found doesn't overturn the IAU vote, it just makes the vote feel embarrassingly incomplete. Every model we had said Pluto would be simple, quiet, and geologically dead by now. Instead, New Horizons sent back images that made planetary scientists question their most basic assumptions about energy and heat. A world that small, that far from the sun, had no right to be doing any of this. No right to have mountains younger than the dinosaurs, or plains that resurfaced themselves without any obvious source of power. And yet there they were, undeniable, sitting in the data at 3 billion miles away. If Pluto could hide this much complexity, the outer solar system isn't a graveyard, it's a place we simply haven't looked at closely enough. Every icy moon, every dwarf planet drifting past Neptune, is now a question we don't know the answer to. The real lesson from New Horizons isn't what we found on Pluto. It's how wrong our confidence turned out to be.